In the second part of this lesson, we are going to talk about the variance and the standard deviation for a discrete random variable. We're going to start by thinking about the random variable that I asked you to think about at the end of the previous video. So the random variable was x, such that x represents the number of heads that you can get after flipping a coin twice. In creating the probability distribution for this variable, you should have found that the probability distribution was given by these values in this table, where we could only find 3 outcomes. We could have 0 heads, 1 head, or 2 heads, and the corresponding probabilities were 1/4 for 0 heads, 1/2 for 1 head, and 1/4 for 2 heads. Now, I want you to think about the mean. How do we usually calculate the mean? In this case, the number of outcomes, or the value of the outcomes that we get, are 0, 1, and 2. If we wanted to look at what is the average outcome, we would add these 3 values, 0 plus 1 plus 2. And then remember that 1 came out twice. There were 2 possibilities, or 2 ways in which we could have got, as a result, 1 head. So that means in total we have 4 outcomes. And if we wanted to say what's the average number of heads, then we can just add all of these and divide by the number of possibilities that we have, which is 4. We have 4 possibilities, 4 possible outcomes, and the addition of them is going to be 4 out of 4, which is equal to 1. So in average, we should expect to get a 1 as a result of this experiment. We can do one more thing, and it is that we can distribute the 4 in the denominator to each of the elements in the numerator. So we can write this again as 0 times 1/4 plus 1 times, it appeared 2 times, so I'm just going to write 1 times 2 explicitly, and then divided by 4, plus 2 times 1/4. So we're going to get each of the values of the possible outcomes, 0, 1, and 2, but they are multiplied by their corresponding probabilities. So one way that we can look at this is by saying, okay, to calculate the average of my probability distribution, what I can do is I can take the individual values and I can multiply them by their corresponding probabilities. This is called a weighted average. So in general, what we're going to have is that the expected value, or the average of a probability distribution of this kind, is going to be given by the sum of all of the products for each of the elements. So in this case, say we have n outcomes, it would be the sum from 1 to n, all of the products of the probability for each of the outcomes times the outcome itself. And this is giving us the average of the probability distribution. We're going to call this average the expected value. It's going to be more common that we refer to it as the expected value than the average. Now we can look at how do we calculate the standard deviation or the variance for this probability distribution. For a set of n values of x, we usually use this expression to calculate the variance. And that expression is much more general, and we can use it also for probability distributions. What is the most common way in which we are going to use this expression? We need to manipulate it a little bit before we can actually apply it to a probability distribution. The most common form that we are going to use this comes from the expansion of the binomial that is within the sum. So I'm going to take the 1 over n outside, and I'm going to work with the sum here. We have n outcomes in total, so this sum should go from 1 to n. And we're going to expand these parentheses. So it would be xi squared minus 2xi x mean plus x mean squared. We can do the separation of the sum for each of those terms. And we're going to do it like this. So it's going to be the sum from y equals 1 to n of xi squared minus 2 times the sum from I equals 1 to n of xi x mean plus the sum from I equals 1 to n of x mean squared. And we're going to distribute the n as well. So the sum from I equals 1 to n of xi squared, everything divided by n, minus 2 times the sum from I equals 1 to n of, I'm going to take the mean outside of this sum because it has nothing to do with I. So the 2x mean outside and xi remains inside, and I'm going to divide it by n. And the last one is going to be plus. I'm going to take the mean squared out of the sum because again it has nothing to do with I. So we can write it outside like this. And we're going to have the sum of the values from 1 to n of 1 and everything divided by n. Now with the first expression, the sum of the xi squares divided by n, that's how we would calculate the mean of the square values of x. We're going to call that the expected value of the x values squared. So we're going to represent that with the formula e of x squared is the expected value of the squares of the variable x. Then in the middle, we have 2 times the mean times this expression right here. This is also an expression for the mean. So we're going to substitute that with minus 2 mean squared because this is the mean and this is also the mean. So mean times mean, mean squared. And then the last term that we have is plus the mean squared. And then the sum that we have here from 1 to n of 1 is going to give us n. And divided by n is simply 1. So we have plus x squared, and that's it. Now, we're saying another word for the mean is the expected value. So we're just going to change the notation here. And we're going to have the expected value of the squares minus 2 plus 1 is minus 1. So minus 1, the expected value of the x values squared because x mean is squared. So the expected value would also be squared. This is in general the formula for the variance that we're going to use. So considering that for the distribution that we had for the coin, then we need to expand our table to include the squares of the x values. So let's do that really quickly. Now I have modified the table to include the square values of x, and we cleaned it up so that we can have more space. So to find the variance for the random variable x, which is the number of heads after flipping the coin twice, what we have to do is to calculate the expected value for the x square values. And we're going to do that in a similar way that we did the expected value for x. So the expected value for the squares is going to be the value of the variable, so 0, times its corresponding probability, times 1/4, plus the next squared is 1, times the value of the probability, plus the next square value is 4, times its corresponding probability, 1/4. So the expected value for the x squares is going to be 1.5, so 3/2. We already found that the expected value of x was going to be 1, and if we square it, it's also 1. Therefore, we can find that the variance for this random variable is going to be 3/2 minus 1 squared, which is the same as 3/2 minus 1. The variance is going to be 1/2. Now, if we're interested in finding the standard deviation, what we do is take the square root of the variance. So if we wanted to find the standard deviation, we take the square root of the variance, which means is the square root of 1/2. So the standard deviation would be the square root of 2 divided by 2. And this is how we're going to find the mean and the standard deviation for a discrete random variable. Now it's your turn. For the discrete random variable x that I am presenting you with, can you complete the table for the probabilities? Can you also find the expected values and the variance? Let me know how you do with this next time we see each other.